This is Martin Carlisle with Can You Get Us Me from pico2018. 2018. Can you exploit the following program to get a flag? You may need to think return-oriented if you want to program your way to the flag. You can find the program in this directory on the shell server. So it says this is a classic ROP, and I've gone ahead and downloaded the program. And so you'll see that what it does is it does a getS into this buffer, which is stored on the stack. So I'm going to be able to overflow that buffer and write the return address to whatever I want. Now, what's interesting about this program is it's protected so that the stack is not executable. So I'm not going to be able to put shellcode on the stack as I've done before. But one of the things that the hint in the problem talks to me about is return-oriented programming. And so what return-oriented programming does is it goes to the ends of functions or things just before returns and builds little snippets of code together to make a program do what you want. And so I have a copy here of Ghidra, and Ghidra is a reverse engineering tool that has been released by the NSA. So here's the website for it, NSA.gov resources, everyone Ghidra. And so you'll see that it does disassembly, decompilation. So anything that you might do with objdump in terms of finding the assembly language of a executable. But the other interesting thing that it does is this decompilation. And so what you'll see here is that when I go to vuln in the assembly, it has in Ghidra gone ahead and tried to build back the source code. Now you'll note it's not quite the same as the original source code, so it's miscalculated the size of the buffer, but it's done a pretty good job here, and we've lost the variable names when we've done the compilation as well. Okay, so looking at vuln, we will be able to see that the buffer is 24 bytes below the frame pointer, and so then there's another frame pointer that's been pushed. So this variable is 28 bytes below the return address. That's going to be an important thing to remember. We're 28 bytes below the return address. Now another thing I'm going to use in this problem is called ROP gadget. And so what the ROP gadget tool does is it allows you to specify an executable, and it goes through and it finds all of these little snippets before returns. And with those, we're going to build up to an entire program. So for example, here, if we just look at another function, look at this update vars, and we go to the end of it, you'll see that we could put values in EBX and ESI by putting them on the stack, having the return address go here, it'll pop two more things into these registers, it'll return again. So it'll take whatever the next thing on the stack is and it'll go there. So basically we piece together a number of these things just before returns to get a program. Now the other interesting thing is on the Intel architecture, you'll note that not all the instructions have the same number of bytes. So if we were to find a return in the middle of an instruction, we could actually look at the bytes before that and view them differently to see what kinds of instructions might occur. So on the shell, I've downloaded this thing. One of the things that the problem authors have nicely done for us is they've statically linked in libc. So there are lots of functions here for us to possibly get what they call gadgets out of. And so what the ROP gadget tool is now going to do is it's going to look through the executable at all of those return addresses, and you'll see that it found 11,758 unique things that it could do. So lots of these involve being able to load values into registers. Here's some things that modify the stack pointer and load values into registers. Here we have the ability to modify memory. And so we could try to go through all of these manually and try to piece something together. But the ROP gadget tool will also build this whole thing for us. So you'll see that I can actually ask it with some arguments to go ahead and build a ROP chain. So the ROP chain will go ahead and generate the calling of bin shell for us. So we'll run that. It's going to go through, look at all of those things. And here it's popped out a convenient little Python program. So it needed to find gadgets that allowed it to write into locations of memory. It needed to be able to get a syscall number and get arguments to the syscall. So here's the Python program. So it's going to first jump to this address, which will put a value in EDX. There's a value. It's going to pop into EAX. And then it's going to move into a location of memory. And you'll see it's putting bin shell, popping things off the stack and loading them into locations of memory. So it's managed to write bin shell into memory. It now zeroes out EAX, stores it, loads some registers. And now here it needs to build the number for the call to the operating system for the syscall. And so it simply zeroes out EAX and then jumps to this address, which will add 1 to EAX and return a lot of times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it actually manages to load 11 into EAX by doing 11 different returns. And then it does the syscall. And so that syscall now is going to do bin shell. So it's written this entire Python program for us. It needed to know how big the padding was. Earlier I told you that we were 28 bytes. So I've copied that into this little Python program. So I got all of this from ROP Gadget. I've added the 28 bytes. Okay, now I'm going to cd to the folder that contains the problem. And I'm going to run that Python program. And I will output that to get us input in my directory. I'll now take that so you can see there's the output that was generated from the Python program. There's lots of unprintable characters, the 28 A's, the bin shell, and with that, what I will now do is I'm going to take that input and standard input. So I'll So I'll take that file and then I'll read from the keyboard and I'll pipe that into the getUs program here. So that's going to do the overflow. It'll do the ROP gadgets. It now has opened a shell. I can do an ls. I see there's the flag. I can cat the flag, and now I've solved the problem.